So, good morning everyone. Just want to welcome you all here today to the first SIGRA NGN in-person event for a long while. So, great to see people actually in a lecture hall like this. So, so we'll get on today to today's workshop is about offshore wind energy, a kind of a diverse kind of look into what's involved with wind energy and kind of where we'll see it going forward and what to expect. So, we'll just touch briefly on kind of the summary. So, apologies a few minutes late starting today. We just some technical difficulties we just needed to clear up, but this will be kind of a summary into what we'll be actually running at today's event. So we'll start off with an introduction, a kind of a brief overview of what SIGRA is, who the SIGRA NGN is, and kind of give you a bit of a flavour of that. Then we'll get into the nitty gritty of our three great speakers today. We'll have Conor Martin, Matthew Groach, and Darren Reap. So look, there'll be, after all three presentations, there'll be kind of a question or Q&A session with a panel discussion. So unfortunately I think the Slido, you can use it, but I don't know whether the signal here isn't great, so you mightn't get through, but we can always use the good old raise your hand function in person. And then afterwards just closing remarks, and there'll be food and refreshments outside before the site visit. So I might just touch briefly on, I suppose, who SIGRA are, and for some of you who may not know, SIGRA is a worldwide organisation that kind of facilitates the transfer of knowledge between kind of different areas of the industry. In terms of this map here shows, I suppose, the diverse nature of where all the SIGRA organisations are across the globe. So it's a great kind of learning platform. It includes 90 plus countries with 60 national committees. At the moment, currently there's 1,500 members. That's always constantly growing, with 1,250 member organisations. So that's kind of who SIGRA are, but you probably might be wondering who the SIGRA NGN are. So the SIGRA NGN, or NGN, stands for Next Generation Network. So this is kind of the young professionals element of the SIGRA organisation. And what we do is we basically give the platforms and give the areas for the transfer of knowledge and to develop the knowledge of young professionals in the industry. Young professionals in all across the industry, airgrid, ESB, various different areas. And we do this by industry related events, such as today on the topic of offshore. We ran various different kind of presentation and events on various topics in the industry. Site visits, including, I suppose, later on in the visit to the wind farm. Networking opportunities, and we also provide a platform for early professionals to present on some of the work that we've done. So we've had some great presentations throughout the years from young professionals. Also, we kind of promote and kind of encourage young members to get involved in working groups on certain topics in the industry, and then to present and kind of input into technical events. So in terms of the Irish NGN committee, so myself, I'm the chairperson of the NGN. We have some of the committee here today from various different areas of the industry, including airgrid, ESB, smart wires, EPRI and UCD. So you can see that there's a broad range of inputting into this committee to provide those kind of networking opportunities and technical events. And look, if either after this presentation or in the coming days, if you're interested in getting involved, please get in touch with any of us. We'd be happy to kind of get as many in as we can. In terms of a bit of background on the Irish NGN from the start, so we were formed in 2018, and since that we've had a steady active membership with currently 92 members, and that's kind of been gradually increasing every year at a rate of 40%. Through our industry events, virtual events, we've engaged with various different people, including about 100 individuals roughly. As you can see here, there's a lot of kind of companies involved, such as universities, ESB, airgrid, and other kind of elements. So it's a quite diverse kind of network. And our membership range, you can see, kind of goes from 22 right up to 35. So there's a broad range of input. In terms of the kind of some of the events that we've ran, so the three pictures down below here, this is a site visit we took to EWIC, the East-West Interconnector, talking about interconnection, and it was kind of, I think, just pre-COVID, I think, so it was the last probably site visit that we did. And we've also done a lot of kind of collaboration events with different kind of countries, such as the French NGN, the UK and others coming down the line as well. And then other kind of industry related, such as the women in the power system industry, which we've ran with Engineers Ireland today. So that's kind of an overview of SIGRA NGN. And look, as I said, if you're interested in getting involved, please get in touch. We'd be happy to get as many members as we can. Now, to suppose introduce the topic today and to talk about kind of wind energy and the development of offshore, and kind of a look at the present and then a look at ahead, and to introduce the speakers. So currently on the transmission system, we have approximately 5,000 megawatts of installed wind energy onshore on the island of Ireland. This includes over 250 wind farms in the Republic of Ireland. The largest wind farm is located in the west of the country in Galway with 169 megawatts. The only existing offshore wind energy connected is the Arklow Bank wind farm with 25 megawatts. So we currently have 25 megawatts of offshore, but obviously, as you'll see from the presenters today, there'll be a lot more coming down the track quite quickly. And I suppose that's kind of a look ahead into this presentation to see what will we expect coming down the line before 2030, hopefully, and get a better perspective of what's involved with actually connecting a wind farm from both the construction side, the policy side, and then also the actual kind of the roadmap into what's coming down the line. So hopefully coming out of here you'll have a bit more knowledge on offshore. Hopefully I will anyway, and hopefully you all will as well. So we have three fantastic speakers today which I'll introduce. Conor Martin will be our first speaker. Conor has 10 years experience working in the power generation across O&M, construction, asset management and asset development. Conor currently works in the role of Senior Project Engineer with the Offshore Wind Asset Development Team in ESB Generation and Trading. Our second speaker today will be Darren Reap. Darren is a civil engineer with the Offshore Wind Team in ESB, Engineering Major Projects. Darren has been involved in various technical assessments and physical characteristic studies for offshore wind farms in both UK, Ireland and Scotland, so great background there. And last we'll have Matthew Groach from Airgrid. So Matthew is an engineer in the Future Networks department at Airgrid, and he's been involved in various techno-economic studies of the future power system, as currently part of the team working on shaping our electricity future. So he'll give a bit of background on that. So we'll have Q&A after all three presenters, so hold your questions till the end and we'll kind of open the floor up, and Katie, my colleague, will kind of be taking some of those questions. So I'd like to introduce our first speaker, Conor Martin. The floor is yours there, Conor.
Thanks, Conor. I'm also Conor. Can everyone hear me okay? Okay, perfect. Okay, so thanks for the introduction and thanks for the invitation to speak today. As Conor mentioned, I'm Conor Martin. I'm working in ESB's generation business in the asset development area, focusing on the development of offshore wind farms. ESB is actively developing projects in Ireland and the UK. I suppose my focus area is on the Irish market. So what I'd like to cover today is a very brief introduction to offshore wind and I suppose some of the relative benefits of it when compared to onshore. I'll go through some of ESB's plans and ambitions for the sector, and then an overview of the market for offshore wind in Ireland. So why go offshore? What's the benefits of offshore wind? So I suppose there's some maybe fairly obvious ones. You've higher wind speeds, so greater wind resource, a more consistent wind supply. So overall you can get higher load factors from offshore wind projects. But I think a key feature and something that's really allowed offshore wind to diverge from onshore wind in recent times is the size of the turbines that's possible to install offshore. So that's been a major factor in the cost of offshore wind coming down and it becoming more competitive relative to other renewable technologies. And then the other key thing really is the size of the arrays, the size of the wind farms. So as Conor mentioned, the largest onshore wind farm in Ireland is 169 megawatts, whereas most of the offshore wind projects that are in development today would typically be of gigawatt scale. These would be 1,000 megawatt projects, and certainly in the first batch of projects that will come through into the Irish market, hopefully in the years to come, you'd expect the smallest of those to be 300 to 400 megawatts and some up to 1.5 gigawatts in scale. So a huge difference in terms of the size, the economies of scale and the benefits that can bring to the levelized cost of energy. And then maybe another, I suppose, benefit or maybe a restriction around onshore wind and the size of the turbines is the transport and logistics piece. So as the turbines become larger and larger, the tower bases can become so wide that it's actually difficult to transport them on roads. If you're trying to get a tower base that's 5 or 6 meters in diameter along a kind of a narrow country mountainside road. It's just not really feasible. Whereas with offshore, that can all be placed on a barge and just shipped out to the install location. So you can see there the kind of the evolution in the scale of the turbines and I suppose how quickly they're advancing. So this is almost slightly out of date. This is probably a couple of years old. But you're going from 2 megawatt turbines sort of 20 years ago through to 8 and 9 megawatt turbines that would have been installed around 2017, 2018. Currently, turbines being installed will be about 10 megawatts. And certainly a lot of the projects that are being developed in Ireland with the view to installation post 2025 will be looking at turbines of the scale of 15 megawatts plus. So really kind of significant size components, really impressive engineering, and I suppose that's the evolution of the sector is one of the things that's allowed offshore to become that bit more competitive. So I suppose what's ESB's interest in this, or why are we looking into it? So ESB's sort of recently launched net zero strategy with the target of being net zero by 2040. A kind of a key milestone on that journey is to have 5,000 megawatts of renewables by 2030. And 2,500 megawatts of that is planned to be from offshore wind. So 50% of the overall volume of renewables that ESB owns and operates. But if we look at, I suppose, some of the metrics on that net zero strategy, and I don't plan to go through all of these line by line, but if you look at the first line there, our current installed capacity of renewable generation is 976 megawatts, so just under a gigawatt, predominantly onshore wind and also the hydro assets around Ireland. So that's intended to increase fivefold by 2030, so in 8 years, and 2,500 megawatts of that from offshore wind. So getting to that milestone, offshore wind is going to be a real key driver and a key enabler of that. So I suppose what I'll try and go through now is how ESB's tried to kind of take steps into the offshore wind sector to try and build a bit of experience and know-how of offshore wind. I suppose we've been operating and owning onshore wind farms for quite a long time now, quite good experience of that sector, but offshore wind, and particularly maybe the marine environment aspects of it, are where a lot of the challenges come, and it wouldn't necessarily have been an area of much historic experience. So this was the first foray that the company took into offshore wind, was purchasing a stake in the Galloper wind farm, which is an offshore wind farm off the Suffolk coast on the east coast of England. So that project was close to commissioning when ESB bought a minority stake into it. So it was effectively buying a minority stake in an operational asset. And that was to have a seat on the board, get some experience of the operational issues and challenges that come with running an offshore wind farm. So following then on from that, I suppose we started to move a bit further back in the kind of development and construction cycles. So the Ngartnaguiha project is an offshore wind farm project off the east coast of Scotland. It was developed by Mainstream Renewables. EDF subsequently purchased it once it had gotten to a point where it was ready to start moving towards construction. And then after EDF had bought it, ESB bought a 50% stake in the project. So that's currently in construction. ESB does have personnel working on the project, and once again, this is just about building that experience, that competence, and I suppose learning some of the challenges that come with construction. So that project, I suppose, should start going live in phases, starting from kind of 2023, 2024. There's been a lot of challenges in the project associated with the foundations and the ground conditions. So challenges for the project, but obviously a lot of learnings as well for the company there in terms of the issues you can run up against working in the offshore wind sector. And then the other sort of Scotland joint venture we have is the Inch Cape wind farm project. So that's another one off the east coast of Scotland. So that was even a little bit further back in the development cycle. So not in construction, it was still a development project owned by Red Rock Power. So ESB purchased a 50% stake in that. And that was brought through the various development stages. It went into auction about a month ago and cleared in the auction there last week in the round 4 auctions in the UK. So that's a 1,080 megawatt project of which ESB will be a 50% owner. So it secured its auction contract, and now it's a case of getting it to financial close and then hopefully moving to construction, commissioning and operation. So that's what we have around around GB. If we look at what's in place in Ireland, so a number of projects across the east, south and west coast. So I'll start kind of furthest north there in the northeast. So the Oriel project is an offshore wind project that was owned by Parkwind, and they're a Belgian company. ESB purchased a stake in that, but we'd be, I suppose, a minority shareholder in it. So Parkwind are leading the development of that. And then also the Clogherhead project, which is likely to be delivered after Oriel, but on that one ESB will be the kind of the lead development party. So you can kind of see there's this kind of gradual sort of baby steps introduction to the sector to kind of build more and more experience to get to a point where it's something that we can either run ourselves or be the lead developer on projects. And that, I suppose, brings us then to the other projects that we have around the coast of Ireland. So you can see in the lower red box there the projects across the east, south and west coasts. So these were being developed by ESB and Equinor. So Equinor is the kind of Norwegian state-owned oil company who've started to move into offshore wind, and they'd be kind of a market leader in floating technology. So those projects were being developed. Equinor decided to leave the Irish market completely. So ESB are currently progressing all of those projects on a standalone basis. So there are 7 projects across 5 different sites, a mix of fixed foundation projects and floating foundation projects. So I think Darren in his slides, my colleague from ESB Engineering and Major Projects, will go through some of the different foundation technologies. But typically on the east coast is suitable for the water depths are suitable for fixed foundation type projects. Once you move into the south coast and particularly the west coast, it starts to become challenging in terms of water depths and seabed conditions. So that's where floating foundations and floating technologies become more suitable. So you can see on the west coast there, there's the 2 projects, Money Point 1 and Money Point 2. They're both intended to be floating foundation projects, and they're part of the overall Green Atlantic project. So this is something which ESB launched probably early part of last year, and it's a strategy to convert the Money Point power station, which is ESB's coal burning power station in West Clare, into a hub for offshore wind and floating offshore wind. So I suppose the first phase of that involves using the existing deep water jetty that's there and repurposing a lot of that to allow it to house and assemble components for turbine foundations. And then further on from that, then there's plans that it could be used as a hydrogen hub for production of green hydrogen. So I'll touch briefly on hydrogen a little bit later, but green hydrogen is seen as a potential solution to, I suppose, the likely over-generation or oversupply of wind energy in Ireland, particularly coming from offshore wind. So in terms of the offshore wind and the Irish sector, so Conor mentioned that there's one offshore wind farm in Ireland built all the way back in 2004, which was the 25 megawatt Arklow project, which was a kind of a demonstration project built by Airtricity and GE. So this was back in the very early days of offshore wind, and it was almost to see, well, what's technically possible, what can you do? And then that was the only project that went in. So since 2004, there's been no other offshore wind farm installed around the island of Ireland. And I suppose there's some reasons for that. I mean, like in many ways, it's a shame that the industry didn't kick on, and maybe Ireland could be an industry leader now for the sector in the same way that maybe Denmark or Great Britain are. But I suppose at the time it was seen as a very expensive technology. You know, if the turbines that went in at Arklow Bank were 2.5 megawatts, you could probably install a similar sized turbine onshore, and when you compare the cost on a like-for-like basis, onshore was always going to be much, much cheaper. So the feeling was it was very expensive. We'd focus on the development of onshore wind, and you know that would be where all the support schemes and things like that were focused. So there was never any support scheme in place for offshore wind. Another challenge as well is around what you call regulatory and policy uncertainty. So actually getting exclusive interest in a seabed area in Ireland was very, very difficult. There was no kind of robust process and legislative regime to allow people to secure a seabed lease. It wasn't really clear whether that would sit with the Department of Housing, whether it would be with fisheries, whether it would be with energy. So it was one of these things that just kind of fell between the stools and never really got progressed. And because the focus was on the development of onshore wind, it was kind of left alone by the government. And then I suppose another challenge as well is around the limitations on the grid and the amount of renewable generation it could incorporate. So the amount of non-synchronous power coming from wind technologies that they could bring onto the system and still maintain security of supply. I suppose EirGrid were probably struggling to connect all of the onshore wind projects that were coming through the pipeline without having to deal with much larger scale offshore projects as well. So that's just a kind of a cross section of some of the reasons why we haven't seen any other offshore projects since 2004. But then in probably about 2016, 2017, we started to see auctions around Europe, in the UK and Denmark, where the price for offshore wind projects was coming down drastically to a point where it was becoming more competitive than obviously than it was historically, and almost cost competitive with onshore wind. There was projects going and clearing in auctions in the Netherlands with zero subsidy. So I think at that point, people in Ireland started to take notice of this, to realise, okay, this isn't something that's going to cost a fortune, this is something that's achievable. So they started to take the steps to enable offshore wind to be something that we could see around Ireland. So I suppose what do you need to develop any kind of energy project, so any electricity generation project? So the first thing really is you need land. You need somewhere where that project's going to go. And then once you have that and you can start to design the project, you can then go through and put in for planning permission. That will allow you to then seek a grid connection. Once you have all of that, you can participate in an auction or see some kind of route to market to essentially ensure that there's a business case for the project over its lifetime. And once you have all that in place, you can secure project finance and then, all being well, move towards construction. But with the offshore wind projects, because of that challenge I mentioned earlier, where you couldn't get a seabed lease, you couldn't get exclusive access or interest to an area of the seabed, effectively you had no land for your project. So the projects almost fell over at the first hurdle. So I suppose since we saw those price collapses in offshore wind and it becoming more competitive, the government has been looking into that. So last year an act was passed, the Marine Area Planning Act, and as part of that it made provisions for the setup of an agency called MARA, the Maritime Area Regulatory Authority, and they'll be responsible for issuing seabed leases, managing them, monitoring them, and ensuring everything is done in a kind of robust fashion. So they're intended to be set up in 2023, and that really opens the door then for offshore energy projects, whether it be offshore wind, wave, any of those things, to actually start to look at, okay, I need an area of the seabed for this to put in my project, and then you can present that or propose that to MARA and hopefully secure that. So I suppose as offshore wind has started to emerge as a kind of a viable sector in Ireland, there has been huge interest in the sector. Obviously there's a massive wind resource there, there's a massive coastal area being an island, so there's lots and lots of potential there. So most of the kind of Irish active utilities, the likes of Electricity, Energy, ESB, are all active in the sector. But we're also seeing a lot of interest from major international players, both in utilities and in oil and gas. So I think people are seeing the potential there. So you can see on the chart there's, I suppose that's a display of some of the active projects, but not all of them. There's actually a lot more out there. So there's almost a bit of a mini gold rush there. There's lots of people seeing the potential in the sector and trying to get in on it. So there's obviously projects off the east, south and west coast, but we are seeing projects now coming in around the north and northeast as well. So I suppose there's the potential for, like, if all of these projects were to get away, you'd have more offshore wind generation you could probably meet the peak demand in Ireland, about 10 times over. So there'd be far more power produced than the island actually needs to meet demand. And that's when things like storage and hydrogen potentially come into the picture. as an alternative. Instead of using the offshore wind to meet demand, you can use it to produce green hydrogen, which can be used for transport, industry, potentially power generation and gas turbines. So there's big potential for that kind of offshore wind, green hydrogen kind of partnering together. So what will we see in Ireland over the coming years, or what will we hopefully see? So there's a number of different offshore wind farms in Ireland that were kicking around in kind of various stages of development, for 10 years or more. So some of them they'd agreed leases for seabed areas in kind of like one-off deals really with government departments, or they'd secured grid connections, in earlier auction rounds or things like that. So I suppose these were maybe seen as the most mature of the offshore wind projects that were being developed. So these were, like, when all the regulatory and policy frameworks were being set up, these were kind of ring-fenced and given this relevant project status, which was essentially saying these will be the first tranche of projects which will get the seabed leases, which are known as MACs, the Maritime Area Consent, and they'll also be the first projects that will be allowed to participate in the ORES auctions, so the support scheme auctions for offshore wind. So that they're mainly on the east coast. So there's one west coast project at Skirta Rocks. So I suppose just running through them there, starting at the northeast. So there's the Oriel project, which I mentioned, which is a park wind project with ESB is also an investor in. So that's been led by Park Wind. Going then further south, you've Dublin Array and Codling, just off the Dublin coast there, and in the North Irish Sea Array. And then the kind of the long, narrow one off the Wicklow coast there, that's Arklow Bank, so that's SSE's project, and that's almost a subsequent phase to the initial Arklow Bank project going back from 2004. And then you've Skirta Rocks over on the west coast, which was recently purchased by the Green Investment Group, so Macquarie now own that, and they're looking to bring that forward. So I suppose what's needed for these projects and then other subsequent projects coming down the line to succeed. So the regulatory certainty piece is very important. These are, because of the size and scale of them, they're multi-billion euro projects. So no one's going to put that money in and finance it unless there's a degree of certainty that these projects will likely go ahead. I mean, if you think of, say, a 1 gigawatt offshore wind project, you probably have to spend 100 million on the development of that before you even start any construction. So that's a big outlay for any company to put in, knowing that they potentially might get nothing back. So having that certainty there is very important. And we are seeing that now with the Maritime Area Planning Act. There has to be subsequent legislation put in place to amend, to look at the planning laws to see how planning permission will be managed for offshore projects. So there's a whole area there where that needs to be kind of clarified and made certain for investors in the sector. So the MARA, as I mentioned earlier, that'll be set up next year. They're planning that it will be ready to go from the 1st of January. But that needs, you need to make sure that that's all being staffed by competent people, and they have the sufficient number there to actually manage and process all of the work that's going to come at them. And I suppose that's the same for government departments in general, whether it's the Department of Energy and Climate Change. They're going to be managing lots of auctions. So, to ensure that we hit kind of all of the targets that we have for carbon reduction and renewable penetration, it's important that all of those departments have the right resources to make sure that all those processes can be managed without any delays. And that includes the RES auctions for both, I suppose, the onshore solar projects, but also the offshore sector. Another area which will need some focus as well is around port infrastructure. So there's no port in the Republic of Ireland that can kind of manage offshore wind at present. So any of the ones that are there would need significant investment to allow them to act as construction ports. Belfast is the only one on the island of Ireland that can support offshore wind. So Belfast would have been used to support a lot of the West Coast projects in the UK off kind of Wales and England. So they do have the capability there, although there are some kind of investments and enhancements needed there. But if Belfast is the only port in the island of Ireland and you have 5 or 6 projects coming through at the same time, all looking to deliver around the same time, there is going to be a need for more ports to be able to support that. So there is interest in it. Rosslare have plans for the sector and investment there. as well as Shannon Foynes over on the west coast, and obviously our own plans then at Money Point for the Green Atlantic Hub. But it's important that, I suppose, the investment goes in now so that when the project, it allows them to get, to carry out any enhancements that are needed, so that when we get to 3 or 4 years' time, when these projects are ready to go to construction, that that they're ready and good to go. And then grid capacity and grid reinforcement is an important factor of it as well. So these are big projects that are going to be coming in, connecting in. It's going to increase the amount of synchronous penetration on the system significantly. So I suppose, I know EirGrid are making great strides in terms of how much of that they can incorporate on the system, but that's going to need to be pushed further still to make sure that, on a windy day, we can incorporate as much of that wind onto the system as possible. And that will require reinforcements. There will be upgrades needed on the network to ensure that, I suppose, all of that can get through, and you minimise constraints and curtailment, and you make sure that, I suppose, none of that green energy that's being produced is going to waste and maybe being replaced by carbon emitting production. So I think that's me. So I know you're holding off on the questions till the end, so I think at this point I'll hand over to Darren. Or Matthew, apologies. All right. Thank you.
Right, good morning everyone. It's an absolute pleasure to be here. Can you guys hear me? Right. So my name is Matthew Groch. I'm from the network design team in Future Networks in EirGrid. I've been with EirGrid for just over a year now, so still fairly fresh. And in my team, we focus primarily on the scenario planning activities. So that's publications like Tomorrow's Energy Scenarios and Shaping Our Electricity Future. And that's the topic of my presentation today. So I'm just going to give a brief high-level overview of the Shaping Our Electricity Future roadmap that was published towards the back end of last year. So just to set a bit of context before we get into the meat of the presentation, and I'll do that with this very simple graphic at the top. It's quite clear that we're in the middle of a renewable revolution. And just to appreciate the scale of change, if you look at the amount of Res-E penetration in 2010, where Res-E is the percentage of electricity that's generated by renewable resources, we were sitting at about 10%. That number increased by 2020 to about 40%. And our target for 2030 is sitting at 80% at the moment. So in the matter of 7.5 years, we need to double the renewable penetration in our system. So this glide path en route to net zero is set out by a clear decarbonisation agenda that is sort of backed up by legislation in both jurisdictions, so those being Northern Ireland and in Ireland. And just to look very briefly at what step change is required between now and the future power system in 2030 with that target. At the moment, we have most of our energy coming from onshore wind. So it's somewhere of the order of about 90% of our renewable generation is from onshore wind. By 2030, that mix is going to have diversified quite significantly. So like Connor mentioned, we're expecting somewhere in the region of about 5 gigawatts of offshore to connect to the system. We're expecting solar PV to increase quite significantly as well, and our onshore wind will also increase. So as well as increasing that rate of renewable penetration, we're also diversifying the mix. So that changes the dynamics in the system as well. In terms of flexibility, we currently have 2 operational interconnectors, and we're expecting 2 more across the decade. And other forms of flexibility that we expect to materialize at scale are things like storage, in whatever form that may take, and also things like demand-side management. So we currently have DSUs in the system. We'd expect more of those, but we'd also expect some form of load shifting in the system, so be that in the commercial, industrial, or residential setting, and that'll be enabled by the rollout of smart meters. So that'll be things like smart charging of EVs and so on. And then just to compound the challenge or the problem that we're facing, this picture over here is complicated by the fact that we're seeing a rapid increase in demand, and that's primarily driven by the rapid uptake of data centers. It's not just data centers, it's also being compounded by the electrification of the transport and heating sectors in an effort to try and decarbonize those sectors. So this leads us quite nicely into the Shaping Our Electricity Future roadmap report that, like I said, was published towards the back end of last year. It was published in November, and this was the first iteration of this report. We plan to update it every 2 years, so it is a living document, and we refresh it with our assumptions as we go along. Just to mention, this report did have a target at the time of 70% renewable penetration. So we've now been given a target of 80%, and we're updating at the moment. So this report essentially aimed to develop an integrated vision of the electricity system, and it's an integrated vision in the sense that we consider various pillars en route to the net zero system, and this is just a step on that path. So those various pillars would be things like the network planning aspect, along with the transformation of the electricity market to facilitate this change, as well as the way that we operate the system. And then the final pillar is public engagement, which is quite critical to hit our targets by 2030. So this report is used as a basis to deliver the solution, but it needs to deliver it in a way that is economic, that is pragmatic and robust, and that is also a deliverable solution. So it must be something that we can deliver on. And in a sense, the work was used to articulate the plan for this delivery, but also to create a platform, to create discussions with industry or various stakeholders. So before we published our final roadmap report, we went out to quite an extensive consultation. It was a 14-week consultation period, and we went out to consultation with various grid development approaches. Those approaches were a generation-led, developer-led, technology-led, and demand-led approach. And these different scenarios, I'll just explain them quickly. The generation-led approach was centered around moving renewable generation closer to the load center, so closer to where that energy would be used, in an effort to minimize the need to reinforce the network to accommodate those renewables. Then we also had the developer-led approach, which is sort of the business as usual approach, where we let developers decide where to connect into the network. The technology-led approach is where we use new forms of technology to shift power around the network, so that would be things like power flow controllers and dynamic line rating. And then the final approach is a demand-led approach, which is where we shift demand in the system closer to the renewable resources, so that would be things like shifting data centers out to the west and the northwest. So these approaches all had slightly different assumptions associated with them, and we went out to consultation with them. We did relative economic and technical assessments, and at the end of the day we developed a blended scenario, which was ultimately the scenario that you'll see in the final roadmap report. So what is the challenge of the future power system? Well, like I said, this challenge needs to be met by these four pillars. That's market engagement, operations, and networks. And the challenge is really both on the supply and the demand side and balancing those. On the supply side, we're seeing a massive move from a non-renewable system to a renewables-dominated system, where we see an uptake of somewhere of the order of 5 gigawatts of offshore wind, about 2 gigawatts of onshore wind, somewhere in the region of 1 gigawatt of solar, and half a gigawatt of microgeneration. And on the demand side, we're seeing a rapid increase in the demand level, so somewhere of the order of 50% increase in demand. And that's driven, like I said, by large energy users, so data centers, and also the electrification of electric vehicles and heat pumps. So where is this demand and generation situated? Well, I just focus on a few things on the demand side. You'll see that the large energy users are located primarily in the Dublin region, but based on feedback out of the consultation, we also assumed some of that would shift out to the Midlands and to the south. So that's about 300 megawatts in the Cork, Limerick, and Galway regions. And then focusing on the generation side, you'll see that the majority of the offshore wind like Connor has just discussed, sits along the east coast, and then we also, at the time, assumed some on the south and some on the west, and we're refreshing these assumptions in the next iteration. Onshore wind is located mainly in the northwest and the Midlands, and solar in the south and the east, and then conventional generation in the Dublin region, the west, the south, and in Belfast. So our analysis showed us that there were approximately 50 new projects that we needed to progress through the relevant grid development frameworks in AirGrid and in SONI. So there were actually 52, and I'll break those down in the next slide. But this is a significant challenge because it's in addition to approximately 100 significant projects that are already committed and progressing through those frameworks as well. And those projects are shown here on the map, and I won't work through them. But the way that we structured our analysis is we try to maximize the use of the existing grid and to focus on publicly acceptable deliverable solutions. And you'll see here that there are aspects of those various approaches from the consultation that I showed previously. So, like I said, we need significant new grid infrastructure. It's very complex and contentious, and it takes many years to deliver. And this is a key holding point on meeting our target. So you would have seen from a recent report from Wind Energy Ireland, in order to meet our carbon budget targets by 2030, there's an urgent need to progress these projects as quickly as possible. And that's why the engagement pillar is so important. We need timely consent to progress these projects. So to break down those 52 candidate reinforcements, as we call them, they were called out in the final roadmap. 6 of these were new circuits, and you'll see this on the map, although it's a bit small. Those are highlighted by those green bubbles, but they are primarily in the north and some in Dublin. 32 were upgrades of existing circuits, so that's things like cable replacements, up voltages and uprates, predominantly uprates. 1 new transformer and 13 new technology projects. And those technology projects are the power flow controllers and dynamic line ratings. Right, so in summary, the Shaping Our Electricity Future provides a robust economic and deliverable plan for 2030, and it's just a step on the way towards our transition to a net zero energy system. Like I said, it was the first iteration of this project, and we're currently refreshing our assumptions. And we will update it towards the back end of the year. Our solution accommodates social and economic growth, and it also facilitates a secure transition from a non-renewable to renewable-based system throughout the decade. And I think that's it for mine, so I think I'll hand over to Darren.
Good morning, everyone. My name is Darren Reap. I'm an offshore wind engineer with ESB, and I've been involved in the industry for about 4 years, and I'm currently in the process of being seconded over to the Inch Cape project that Connor alluded to earlier as a transport and installation engineer. I am a civil engineer by background. It's influenced my presentation. I do talk about some electrical equipment, and I do understand that there's expertise in the audience on that area, so feel free to heckle where required. So just to go through everything that I'll be talking through, I'm going to go through a very brief history of the progression of offshore wind over the last 10 years. I'll talk about the main foundation solutions. I'll talk about foundation installation via monopile installation. And then the electrical side, I'll just talk a bit about substations and electrical infrastructure and the offshore substation and cabling installation, and then maybe tying it all up then with the Irish context from a technology point of view. So the progression of offshore wind, it can be seen as a novel industry. The first offshore wind turbine was installed in Denmark in the early 1990s, but it was like a 0.2 megawatt turbine, and it was in a water depth of about 3 meters, so offshore used very, very loosely there. But I suppose over the last 10 or 15 years, that's where the industry has exploded. We have moved from 2 megawatt turbines and small projects, 200 megawatt projects now, to looking at where developers are incorporating turbines up in like 18 megawatt turbines into LCOE models for future forecasting. And as the lads mentioned as well, we're looking at projects about up to 2 gigawatt off the east coast of England, so absolutely massive. But look, where we are at the minute, the average distance for an offshore wind farm now being chosen in the UK and Ireland, I think is 60 kilometres offshore, so you're talking about water depths well over 100 metres, and that's where the industry is going, floating. So, and just to mention that there's 110 offshore wind farms off the coast of Europe currently, or just over that, and the largest turbine off the shelf that you can purchase for a development now is 14 megawatts. So fixed, floating versus fixed solutions. So just starting on the screen from the left and just moving across on the fixed foundation solutions, we have a monopile structure, we have a jacket installation, and then we have a tripod jacket. So with regards to fixed foundation solutions, you're confined to water depths less than 70 metres. The capex for fixed foundation solutions can be very high because there's an awful lot of steel. You're in water depths up to 70 metres, they're large structures, there's a lot of steel, and there's a lot of fabrication intricacies, I suppose, in the development. Transport and installation costs can be quite high because it's not a matter of just dropping them out there. You have to get a vessel to bring them out, and you have to get a vessel to install them. And these aren't cheap, and I'll go through that later. But critically, the technology exists to install a large turbine on a foundation out at sea if it is fixed. The bigger the turbine, the bigger the project capacity. The bigger the project capacity, financials are happy. The opposite side then currently is the floating solutions. So if we start from the left of the floating solutions, we have a semi-submersible with catenary mooring anchoring or cabling system. We have a submerged tension leg platform, and we have a spar buoy system. So with floating systems, they only come into the mix when water depths increase about above 70 metres. For the spar system, the furthest one on the right, you're talking about water depths of about 150 due to the just the layout of it and just the size of it. Strangely enough, it can be lower capex than fixed foundation solutions because when you think about it, there's less steel involved. You can even see it just by the image on the screen. So the capex cost can be reduced. And another cost element to it is that O&M can take place at shore. That if there is large turbine failure or element failure, you actually can unhook it and tow it back to the shore, carry out your O&M, and then send it back out again. Now, obviously, there is weather windows and mid-ocean characteristics that you have to, abide by doing that. But like the option is there. But currently, turbine sizes are limited for now. I think the largest turbine installed offshore on a floating system is a 10 megawatt turbine on one of the spar systems by Equinor that Connor talked about earlier. So where we started with fixed foundation solutions was a gravity-based structure, simple, large concrete unit, over 5,000 tons in weight probably. And that was just sitting on the seabed supporting the turbine, and that resisted all the wind loading and the mid-ocean loading out at sea. Strangely enough, it's termed a craneless technology because you don't actually need a crane to install it. You can float it out, and you can add ballast to it then out at sea, sink it onto the seabed, and there you go. It is quite sensitive to geotechnical characteristics just due to the weight of it. And it's also limited with water depth. So I think the deepest one installed was in Thornton Bank offshore wind farm, and it was 30 metres water depth. So like as we progress further offshore, they're not really a solution that's maybe thought about too much, but they do make good photos if nothing else. Where we are now with foundations is monopiles. Monopiles are the go-to foundations. They are simply a large steel cylindrical tube that's brought out to the sea, upended, dropped to the seabed and installed. There's a lot of engineering understanding with these, they are maybe the preferred method currently. So traditionally they were used in water depths up to about 40 metres, and there was this opinion that they couldn't go any deeper, but I suppose new radical engineering solutions has now increased that up to about 55 metres. But because of the bigger water depths, you're looking at bigger diameters and bigger weight. So the monopile shown on screen is a monopile from the Yunlin wind farm in Asia. It's about 11 metres in diameter. I think it's 110 metres in length, and it's about 2,000 tonnes, and that's just one unit. So, but as I said, they're the first choice solution up to 50 metres water depth. After that, then you're in jacket foundation range. So a jacket foundation, as you see on the left of the screen, is just a steel lattice structure. It's leaning on well-established engineering understanding in the oil and gas industry, because these are the foundation solutions that would have been used on a one-off offshore rig. But as we move into serial production required in offshore wind, the jackets aren't as big, but there's a lot of steel, and because it's, as I say, in serial production, you know, you might have 50, 60 turbines, 60 foundation units. There's a lot of welding and intricate bits of fabrication, and obviously quality checks then, and that slows down the process, and as you slow it down, you just increase the cost. These are just lowered down onto the seabed, onto pre-installed piles usually, so these are just mini versions of the monopiles, so usually in a 3 or 4 pile layout. So yeah, fabrication costs can be quite high. So how do you install one of these? Well, you need heavy lift vessels. They are huge vessels that just basically transport the foundations out to their desired locations. The image on screen shows a monopile installation. So the monopile would have been brought out on the deck of the ship. It would have been up, so it's transported out horizontally. It's upended by cranes, huge cranes that you can just see out of screenshot, and it's lowered in off the side of the vessel through a pile gripper. And these vessels aren't cheap. You know, you're talking about in excess of £100,000 per day just for one of these vessels to rent. And when the monopile is hanging off over the side of the ship in the pile grippers, you drop a hammer or a vibration hammer onto the top of it. This is one by Menck, and basically it's a hydraulic hammer that falls across a steel plate that's inside there that just distributes the force evenly across the monopile and forces it down. Alternatively, if you encounter some hard rock or hard substrate, which isn't what we desire, you can drop a drill, which the images on the right of the screen show, down through the monopile, and if you see the schematic, it can drill out the rock or the hard substrate from the inside, and it just eases the process for putting the monopile down into the ground. So offshore substation and electrical infrastructure, simply putting it, it's offshore wind electrical infrastructure usually incorporates a centrally positioned substation within the wind farm boundary, linked to all the turbines via inter-array cables that would be laid out in individual strings or tie-in loops, and they feed back into the substation, and then the power is transferred to an onshore substation along the coast usually, via the export cable routes. Cables have been a point of large claims in offshore wind farms, so like there is huge pressure to get the methodology right for installation and reduce cable lengths. It's a costly side of the development. So with the offshore substations, they're not small units. They're usually multi-deck structures. I was at one. I got a tour around. I finished one there about a month ago in Rotterdam, and it was about, just to give you an idea, similar to the one on screen, it was about 40 meters square in plan, and I think the one I was on was like 4 or 5 levels high. So these are usually just transported to the quayside by what's called an SPMT, so it's just a self-propelled motion transport. Anyway, the image mightn't show up too clear there, but it's like a trailer system with loads of wheels, and it's transported to the quayside where it's lowered onto a barge and it's just towed out to sea. The usual makeup of the substation, you know more about this than I do. The substation elements of the offshore are the substation platform. The substation electrical elements are usually on the upper deck, and then the lower decks are kept for cable tie-ins and the export cable routes and auxiliary systems. Again, to lift, the substations aren't small, but they're bigger than turbines, so you need bigger vessels to install. And some of these vessels are absolutely huge. They have lifting capacities of about 10,000 tons. The substation could be up to about 3,000 tons, but they make it look like it's a toy, just the way lift it up and just swing it around. And it's very, very impressive. These vessels cost over €200,000 a day to rent to install your substation, so it's critical that you get your weather windows right and there's no delays, because like 200,000, or could be up to €300,000 a day is a very expensive thing to get wrong. Just a quick little story about the vessel down here on the right of the screen. This is the Harima. The story is actually related to the sister ship, the Slipner, that we have engaged out in one of our Scottish wind farms. I was at a talk there recently, and one of the people working there said, "Oh, the captain and one of the workers are very good friends. They played basketball together." And I was like, "Well, they're different." Someone said they're different nationalities. Where did they cross paths to play basketball together? And they're like, "Oh no, there's a full basketball court underneath the deck, along with like a full gym and cinema room and all that." So it just gives you a feel for the size of these structures. Offshore cabling, yeah, look, you probably know more about this than I do. It's either HVDC or HVAC systems. We're seeing HVAC systems being incorporated to offshore wind development design now, because the offshore wind developments are getting pushed further and further offshore. And to do that, so it says there, in excess of 100 kilometres offshore, and a lot of the sites being chosen now, the low-hanging fruit sites on nice sandy banks close to the coast are gone, so we're moving further and further offshore. But with HVAC, you have to incorporate a reactive compensator system. I actually don't know what they are, but all I know is that I have to pick a location where to put another jacket structure to support one intermittently on the cable route to shore, maybe 2 extra foundations. The array cables, yeah, look, they're typically 66 kV, even though I think I seen something on LinkedIn last week where technology now they're going to increase that, but I don't really know too much about it. Dynamic cables, yeah, with floating wind, there's a bit of a, I don't know if the technology is caught up yet, maybe someone in the audience might know, but I think with floating foundation solutions, we're still incorporating a fixed foundation substation, because when you have a dynamic cable tie into a moving structure, it's putting undue stress on the cable connections, and as I was saying to you, cable issues can be quite expensive. But like everything, the technology will come around. It mightn't be just ready now, but it's just around the corner. So with the offshore cabling, it's not just a matter of putting these big spools of cable onto the vessels and just dropping them into the seabed. Often you need pre-installation surveys just to see what the seabed is like, through geophysical means. So you pick up any boulders, debris, shipwrecks, UXO, which would be like unexploded ammunition. So like if you're along the east coast of the UK, down to World War I and World War II, there's a lot of ammunition dumped on the seabed, so you have to check for that. But more often than not, you need a clearance or a clearance campaign then prior to cable installation, which the schematic at the bottom of the screen shows. So it just shows a grapple lifting up and maybe a large boulder, and a boulder plough might be the best term to being towed, which just clears off the seabed for the whatever cable installation technique then you incorporate it. Then just start winding things down. Within the Irish context, look, monopiles are the go-to foundation solution. As I was saying, the engineering exists to understand them. There's a deep understanding with monopiles, their use, their capability, but they're limited to about 50 metres water depth. So the map of Ireland shows the 50 up to about 45 metres water depth shown in green. Along the east coast and the south coast, you have a bit more of a gradual reduction or a gradual increase in water depth, so it's not as sudden. So that opens up a whole lot of area for monopile use and fixed foundation solution use. So you can move your site location further from shore, and the further you are from shore, the less landscape and visual impacts you incorporate into the project, and less planning issues you'll encounter, obviously. So that's going to be. It'll be a fixed foundation solution market down along the east coast and the south coast. But if you see with the west coast, the green areas are very close to shore. The Atlantic Ocean gets very deep very quickly, And with fixed foundation solutions, your options are very, very limited. So it will be floating foundation solutions that'll have to be provided for off the west coast. Look, there's very harsh mid-ocean conditions off the west coast in the Atlantic. Strong waves, strong winds, big waves, currents. So as floating industry sort of evolves, it might be a case of just let it evolve. It is evolving on the UK. Take the lessons learned and then apply it to whatever developments then get the go-ahead off the west coast. But the way offshore wind is going, like that's like only a few years away, not decades. So just to finish up, offshore wind, like it definitely is a buzz term these days, and it's getting a lot of media traction. I suppose we have set aggressive renewable energy targets, both like at a company level for ourselves, like we're very ambitious targets that we have to hit, but also at an Irish level. And with offshore wind, as the lads were saying, like you can get one development that gets 1 gigawatt of energy. So in one project, like you can take a massive leap towards, your renewable energy targets. Now it is good to have a diversified range of renewable energy production through solar, through onshore wind, but I think this quote by the KPMG energy report last year is key. Offshore wind is the only technology with the scale and deployment capacity to meet this demand in full, and the demand being our energy targets. So look, I'll leave it there. Thanks very much for your attention. Happy to take questions straight away afterwards, but alternatively I will be hanging around for a cup of coffee afterwards, so feel free to come up and have a chat.
Hi everyone, I'm Katie. So I don't think there's reception at the moment, so I'm not sure if anyone was inputting questions into Slido or that. But if anyone has any questions, as Conor mentioned, we'll do the old-fashioned way, if you raise your hand. But maybe to start off, we might do a few general questions to the panel. So I suppose, Conor, you mentioned in your presentation a lot of other projects that are ongoing, say, in Scotland and that. But what would be the main learnings from other countries that we can take and incorporate into some of our projects in Ireland?
I suppose at a project level, can everyone hear me okay? Should I use the microphone? At a project level, there's experience built from what types of foundations are suitable in certain locations and what kind of planning and logistical issues you come up against. I think a key one is around the development of the supply chain to be able to support the industry. So I mentioned ports as well, that's a big thing, and there's a whole kind of offshore support network that can form around that. So I think Ireland can look at how that's been done in other countries, where hubs have been set up and how that's been used to regenerate certain parts of the country. I think that's a kind of a big learning Ireland kind of as a nation can take on and use to build the sector here.
Yeah. And I suppose Darren and Matthew, from your perspective then, is there any measures that can be improved? I know Matthew, in your presentation you mentioned like the planning stage that had to be overcome, and there was a committee kind of formed to improve that. Is there anything else that can be developed to improve that process?
I suppose just early engagement to bring the public along the journey with you. I think that's why we do, from a shaping perspective, we have our energy roadshow where we go to the different counties and we tell people what projects are planned for their area, just so that when those projects do come up, there isn't a lot of resistance and people have bought into the ideas and the reasons that we are progressing those projects.
Yeah, exactly. And then I think, Darren, in your presentation there, you alluded to some of the size of the substations and installing the foundations. Like the sheer mass of those substations being installed, I'm sure the weather and wind and waves play a part. How difficult is it to kind of predict the installation and that?
Yeah, there will be like expert net ocean modelers involved from the outset to predict weather windows that would target times during the year with lower waves and lower wind. But still is difficult, like with a 2,000-3,000 ton structure raised up off a floating vessel, trying to lower it down onto a jacket, you know, in water meters, early water depths of about 50-60 meters. It's not easy, but there is good technology there. I know the most recent one that has been installed, they utilised stab piles or stab sticks, basically on top of the jacket structure. There's like three sticks up out of the platform, and they're at different levels. So the crane operator just has to target that one stick, so they're on a triangle format. So that larger one, so if it sits down it, then it has to get to the next one, and it has to get to the next one. So it really helps the crane driver. So that's maybe, you know, a bit of innovation in installation and stuff, and constantly refining. There could be new stuff out again, you know, over the next few years. But that's where it was at just up until a few weeks ago.
Very good, very good. And I suppose I'll ask one more question, then I'll open the floor. Matthew, in your presentation, you mentioned the targets for, I know, to achieve net zero by 2040, but for 2030, what do you think some of the main challenges that are associated with it to achieving this renewable ambition by 2030?
There are lots of challenges. I think there are a lot of things that have to go right. But I suppose if I had to pick out some of the main challenges, like I said, public acceptance, deliverability is very closely related to that. So we need the infrastructure projects to progress as quickly through the grid development frameworks as possible and to be constructed on time. Yeah, I suppose some of the other issues are mainly related to the difficulty in the analysis. Going from 40 to 70% was a challenge, but going from 70 to 80 is presenting a whole new set of challenges, particularly in the way that we operate the system. So, like I think Connor mentioned in his presentation, system operations are doing lots of work around relaxing those operational constraints. At the moment, they've recently moved to a 75% SNSP limit, which means that at any given time, only 75% of the electricity you generate in the system can come from renewables or non-synchronous sources. By 2030, we expect that to reach 95%, but there's a whole process, and it's very tricky in achieving that, where you have to go through these extensive trial periods and test the system and see that it can operate under those conditions.
Exactly, yeah. I suppose, are there any questions from the floor at the moment? Yes?
Yeah, I was just wondering, there seems to be an awful lot of development of wind farms on the east coast of Ireland, but why not on the west coast of Ireland instead? Why is it a lot of farms on the east instead of the west, where the open ocean is available?
I suppose there's a couple of these. Maybe Darren will be able to talk through some of the technical challenges. I suppose on the east coast, the water depths and the sea state conditions are a bit more kind of amenable for installation of offshore wind. I think as well, you also have the benefit that any wind farms off the east coast, they're close to the big load centres in Dublin, where where the demand is. Obviously, the challenge with putting in projects on the west coast is that there's already a lot of wind generation in that area, and there's already challenges in getting all of that, the generation from that area to the load centres where it's needed, whether it be Dublin, Cork or Belfast.
Thank you.
Thanks, sir.
Yeah.
We've just gone through this, so the world's in a bit of a fuzzy place, macroeconomically speaking. And you were mentioning that the first wind farm was made in 2004. Just looking at that, that was kind of at the height of the Celtic Tiger. So that development would have had a lot of money behind it. And then, you know, that gap from 2004 to now, you know, it's had a bit of a economic back, you know, from 2007 onwards, we're still catching up on ourselves, and now there's talks of a looming recession, et cetera, and stagflation. Is that forecasted into your economic models to get your targets up to that 80% of RESE in 7.5 years of development with supply chain issues and construction availability?
Yeah, I suppose there's certainly like the ambition is there, you know, from like European level, you know, from Irish government level. The ambition is there. I suppose what we might see is that the cost of delivering projects in that period might be a bit higher than it was 4 or 5 years ago. So, you know, it's around 2016, 2017 when we were seeing these very low prices coming through in auctions in the UK and around mainland Europe. I think projects will proceed. I think the ambition is there in terms of meeting the carbon targets, but they might not be as cost competitive. But certainly it feels like the ambition is there, and while there might be a recession coming, we might see commodity price increases. So with all the steel that's required, these projects will cost more. It feels like they'll still press ahead with developing and delivering those. Because I just think the kind of climate emergency piece has become so kind of central to people's thinking that even if there's a recession, it feels like the push to achieve those renewable targets, that's not something I think that will be compromised if a recession were to hit. I don't know if anyone else has any viewpoint on that.
Yeah, I agree. The climate issues aren't going to cause like the economy to get back up again, you know.
So I just thought it's even like will the demand supersede development? Like you see at the moment,
I think the
doubling down on
development,
coal.
the developments can carry the economy too because it's keeping people employed, you know. These projects will be thousands employed, and we see the emergence of new industries in Ireland that haven't been here before. So,
Yeah.
we have to go along with like a.
I think even if demand were to drop, you know, if global GDP drops and you see a drop in demand, there'll still be, you know, older power stations being retired from the system and you know, fossil generating plants closing, and there will be need to replace that, and I think a lot of that will come from low carbon sources. So even if electricity demand stagnates, which I don't think it will. I mean, even if there is an economic downturn, you'll still see electrification through heat, transport, and I'm not even sure if the data center development will slow down that drastically, even in a recession situation. So you'll still have the demand there, and you'll have old thermal sources retiring. So I think that will be replaced in the main by offshore wind and other kind of renewable and storage solutions.
And the latest generation capacity statement that is due to be published soon sees an increase in the demand level, and it does take into account the economic climate. And that, well, I'm not sure how much of that is to do with data center demand. Certainly electrification and the other industries play a big role there. So I also agree, I don't think we'll see a slowdown in demand. And in terms of the renewable ambition, there's a chance that our targets will be pushed further even still, especially with the emergence of the repower package. The impending climate action plan is due to be released, I believe, in autumn. There is a sense that our targets will become even more difficult to meet. They will become even further.
Just in terms of like the port infrastructure for offshore projects, what are the kind of main components of the infrastructure?
I suppose if ports being used for construction, there's a certain amount of load bearing capacity that's needed because you might be storing very heavy turbine and foundation components there. Just making sure that that's in place, and then there's the actual the depth of the harbour, the water see for an offshore construction project. So the components themselves for the turbines might be built in Denmark or Germany, and they would be brought from there and kept at a port local to the project as a kind of a staging port. So you need the cranes with the capacity there to actually take all of those components and put them into storage. It needs quite a large acreage in terms of the actual area. And so all of that, there's investment associated with putting all of that in place. And what some of the lot of ports and harbours in the UK who have been supporting offshore wind and would have invested in the infrastructure like cranes and things like that. But and even when they were designing that, they would have been future-proofing it for a certain size of turbine component. But actually what they're seeing now is that the turbine components that are coming along are actually bigger than what they future-proofed their cranes and their handling systems against. So a harbour might have done an upgrade 5 or 6 years ago and are now finding that they're going to maybe have to do another upgrade after quite a short period of time, just because the evolution of the size of the turbines and components has probably accelerated way beyond what anyone would have expected, maybe 6-7 years ago.
I think the problem with ports as well is that the ports that have the deep harbour access are the ones that don't have space for holding turbines, like the bigger city ports. And then the ports that are regionally placed that have loads of space are shallow access ports. And you're like you said about investment, huge investment will be needed because storage is critical. Like if you have a port in the city, you can't buy space. But if you have a small regional port with space, you can dredge it, you can get your crane, you can upgrade it. And you'll probably see the emergence of regional ports. But I suppose that's where sort of Pleasant Ireland Money Point is very well placed for all that. That it does have deep access and plenty of space for set down areas and marshalling and etc.
Very good. Suppose if there's one last question, yeah.
Yeah, just in terms of maybe I'll just say, I suppose as there's more synchronous, non-synchronous energy generation, you sort of expect, maybe you could agree or disagree, but is it going to continue to be wider swings in the price of energy at a given time? For instance, you've seen some battery projects make massive amounts of money in a given hour or stuff like that. How does that affect sort of bidding into auctions for these offshore winds, where you'd expect a lot of Irish offshore wind to be synchronized with itself, I suppose, and therefore prices when it's windy to be generally lower than the rest of the time? Just the uncertainty around that, how do you come up with auction prices as it gets more, it's almost like a bit more of a win,
Yeah,
the harder it would fare.
I suppose the way the renewable support contracts are set up is almost to give you a guaranteed price for, maybe not for the full lifetime of the project, I think typically for the first 15 years or so, or in some cases it might be 16 and a half years in other jurisdictions. So you form a price that you think you can construct and operate your asset for, and then the fact that that gives you a guaranteed price that insulates you to a certain degree against those swings that you see in the system between price spikes and price dips. So
Sorry, just to jump in, has the change in sort of energy prices from the war and stuff like that drastically changed the outlook for the second half of the life of these projects in the last year? Or is the second half of life largely devalued enough compared to the first half that it doesn't make a huge difference?
I think that would typically be the case that as you get that far out, where you're looking at kind of merchant revenue for the tail end of the
just in terms of the offshore wind turbine, like, what would the design life of the foundation be, and what would the design life of the turbine itself be? And when that does expire, what's the plans to like reinforce the foundation? Would it be to put a bigger turbine on? What's the plan? Or and I'd say Arto, for example, like it's what, 15 years plus now older, so like what would be happening in the coming years on that?
I don't know what their plan is. We limited an operation life for the foundation for 25 years, and then there's options to extend then based on surveys and studies. I think it's usually a 5-year extension.
Okay.
But I think I seen one great one when there's a 10-year extension that it was survived that life cycle well. Yeah, 25 years. Then there's decommissioning plans. You know, I don't think upscaling the turbine on a foundation that's, you know, as you're just saying, streamlined for a particular unit. I don't think it would be feasible. Maybe it might be. I don't know what the answer on that. And with turbines, I'm not a turbine guy. I don't know the operation of the actual units themselves. But there is a lot of maintenance with offshore wind turbines.
Okay.
Like what we're seeing in the kind of business cases for upcoming offshore wind projects is there's assumptions around the operational life. I suppose for onshore it would have always been 20, 25 years. We're seeing 30, 35 years coming in for offshore, and that might involve, like I was mentioning, life extensions coming in. So we've seen that in some of our onshore projects where it's coming towards the end of its what was assumed to be its operational life. At the time we bring in some expertise, you might bring in some people from the equipment suppliers, you inspect a lot of the key components, and you might find that actually this has life remaining in it, and so you can carry on operating it safely for another few years.
Very good. I think if there's no more questions from the floor, I'd just like to thank our 3 speakers for taking the time to come. And I think there's food and tea and coffee afterwards. Connor, do you want to say anything else?
So yeah, thanks again to the 3 speakers. Great answers to some great questions. So that's kind of it for today. I think it was a great event for me personally. I think it was great to get the insight from the 3 speakers. Certainly more knowledge as before I came in. So just want to thank the speakers. Great presentations, great knowledge. Great to have you today. Katie, thanks again for taking the panel discussion and some of the questions. Also to the committee as well, the NGN committee. I think there's 5 of us here today, but there's a lot more involved in it, and to kind of thank everyone as well for their input. And lastly, but thanks everyone for attending today. Great to see you in person, or some familiar faces, some new faces. And yeah, if you're interested in getting involved with SEGRA or the NGN, just get in touch with us and we'd be happy to get you on board. So thank you very much.